There are more than 80,000 dams in the United States, and yet only 3% of those generate power. The main objective of this project is to develop a design that will allow a selected non-power dam to generate power. Environmental impact, power output, and geography were taken into consideration when selecting a dam to work with. Melvin Price Loxton Dam in the Mississippi River came out to be the ideal location when compared with other dams in the Missouri and Illinois area. We estimated that it has the potential of providing 30 megawatt of power based on the assumption that we would be able to redirect around 10% of the river's flow through additional channels. The small percentage of redirect was made due to consideration of the original purpose of the dam in the 9-foot channel project. The fluid dynamics for the project were analyzed and were used to determine the design of turbines needed, as well as the channel sizing. Cost and timeline estimations have also been developed for this project.
We chose 4 different possible sites to do our non-powered dam conversion at. This right here is the Marseille Dam. This is the Shelbyville Dam. This is the Pomme de Terre Dam. And this is the Melvin Price Lock-in Dam. I'm using Google Earth so you can just see pictures of them. We picked these 4 places since they were all non-powered and within the Missouri-Illinois area, and they looked like they best fit our project. Using our quantified needs equations, we were able to score these locations and finally pick the Melvin Price location. The Melvin Price Lock-in Dam was chosen mostly for its high overall power potential, good volumetric flow, better fish pathways through this lock area, better expected LCOE, good accessibility from this side. Our working prototype phase of the project, we couldn't actually create a physical model since our dam would cost millions of dollars. So instead we created a estimated schedule of the project and a cost estimation of the project. In our cost estimation, we came up with some different things that we thought would be important and listed off their descriptions, did some math, and after factoring a healthy 25% contingency, we came up to $210 million. And then for our schedule, we listed off some major things that we thought would go into the process of building this thing, came up with some month values from some research, and came up to a final 89-month finish time.
Here's an aerial view of the site we're looking at. This is the Melvin Price Loxton Dam from Google Earth. And next we're going to see the 3D model of what the site would look like with the river drained. We're focused on the Missouri side of the river, this levee and retaining wall. Alright, and here's what the same site will look like after all the excavation work is done. Next is the same site with all the mechanical components added in. That's the gates, trash racks, penstocks, turbines, and draft tube. Here we see the Kaplan turbines and the way they function. And finally we get to the completed project. This is the same site with the foundation built and the powerhouse and surge tanks added in.